Welcome to 81st lecture. We are studying transient analysis of circuits, and in the last few lectures we have been studying transient and steady state behavior of capacitors and inductors. In this lecture we will apply that knowledge and will solve an example containing this resistor, 3K resistor in series with this 12-volt source, a switch, 1000 microfarad capacitor, and 4K resistor, and this 2K resistor. Right. The switch remained it remained closed for a very long period of time unless the circuit achieved steady state, and then it was opened. In previous lectures we have been studying the case where the switch remained open and it was closed suddenly. So it is a reverse case compared to the cases we have been studying before. Here the switch is closed unless the circuit achieves steady state, and then it was opened at time t is equal to 0. And then we have to find Vc of t for all, this is for all t to come after time t is equal to 0. So for this solution, we have been studying that first we will analyze this circuit for its transient behavior. What was the situation at time t is equal to 0 minus when the circuit achieved steady state while the switch was closed? Right. If the switch remained closed for a very long period of time, the capacitor would have been charged because this is a DC voltage source. The capacitor would have been charged to a voltage, a constant voltage, and then the current flow through this capacitor would become 0 and it would be open circuited. So this is the situation after it had attained steady state in while the switch was closed. So just before the switch is opened, the situation is like this. The capacitor would have achieved steady state and is charged at a voltage capital V. Let's find out what that voltage is. For that, we'll assume a node here and we'll write the node equation for this only node in the circuit, assuming this node to be the ground node. So the equation would be V minus 12 divided by 3 plus V minus 0 divided by 6. So it gives us V is equal to 8 volts. This means that just before the switch was opened, the capacitor was charged at a voltage equal to 8 volts. And then what happens at time t is equal to 0 plus? Time t is equal to 0 plus is the time just after we have opened this switch. As soon as we open this switch, this connection is opened, this 12-volt source and this 3K resistor come out of the circuit, and now we have this capacitor and this 4K and 2K elements in the circuit only. These two elements are taken out of the circuit because there is an open circuit at this place. So what happens next is, this is the circuit we are left with after we have opened the switch. So what happens to the voltage across capacitor? We have already studied that the voltage across capacitor cannot change all of a sudden. It cannot change suddenly. So it remains 8 volts even at time t is equal to 0 plus. So this is the same as it was at 0 minus because the voltage across capacitor cannot change all of a sudden. And we have also studied that current through inductor cannot change all of a suddenly. So but what happens at time t is equal to infinity? As the time passes, this charged capacitor, we studied that this charged capacitor works like a voltage source, but only for a limited period of time. After some time, it keeps on discharging, and after some time, it is completely discharged, and we have 0 voltage across it, and then 0 current in this circuit. Right. So this is the situation at time t is equal to 0 minus, at time t is equal to 0 plus, and at time t is equal to infinity. Let's write an equation for all t, for Vc of t, the only unknown in this numerical example. For that, we have to write this KCL equation. We can write KVL equation. If we write KVL equation, we'll find I through the capacitor, and then we'll have to apply the formula the integration based formula to compute the voltage across capacitor. So to make things simple or to keep things simple, just assume a node here and assume a ground here, and then we can straight away write this KCL equation. The current in this branch would be C, the derivative of the voltage Vc of t. The Vc of t is the voltage at this node, plus the current through this branch containing only two resistors is Vc of t divided by the sum of two resistors. So since C is 100 microfarad, we'll put the value of C 100 microfarad, and the 6K divided by 6K, because 6K is the combined resistance of this 4K and 2K resistors. And then if we divide the whole equation by 100 microfarad, this comes out to be this much, this equation A, the time derivative of the voltage Vc of t plus 1 over 0.6 Vc of t. So the general solution for this equation we have already studied is k1 plus k2 e to the minus t over tau, where we have three unknowns, k1, k2, and tau. So how to find the values of k1, k2, and tau? We'll have to put initial conditions first. The initial condition, the final condition. Putting initial condition, Vc of 0 is k1 plus k2, because putting t is equal to 0, e to the minus 0 is a 1. So k1 plus k2 is Vc of 0. What is Vc of 0? Vc at 0 is 8 volts. So we'll put 8 here. So k1 plus k2 is 8. But Vc at infinity is 0. So k1 plus k2 e to the minus, putting putting infinity here gives us e to the minus infinity, which means a 0. So k1 is a 0. And then k2 comes out to be, putting k1 is equal to 0 in equation number 1 gives us k2 is equal to 8. So now we have computed k1 and k2, and the only unknown left is this tau. For that, we already know that we put it in the basic equation. We'll put it in the basic equation, this equation number A. So putting this in equation number A. Putting this 3 in equation number A, computing time derivative first, and then putting Vc of t gives us, and then solving, this cancels because if we divide by 8 e to the minus t on left and right hand sides, we are left with this expression. 1 over tau is 1 over 0.6, or tau is 0.6. So the expression becomes Vc of t is 8 e to the minus t over 0.6. This is a decreasing exponential. We already know that. It's a decreasing exponential. And it is plotted like this. We have already used MS Excel to plot these functions in our earlier lectures. And that's all for this lecture. But at the end, we have a homework for our students. What is that homework? We have computed Vc of t, the voltage drop across capacitor in this circuit. So students are required to find the voltage drop across 4K resistor, across 2K resistor, and the current in this series circuit. So the three quantities that I want my students to solve is I sub C of t, the current flow through capacitor, the voltage drop across 4K resistor, and the voltage drop across 2K resistor. So these are the three unknowns that I want my students to solve as an exercise. So actually it's a homework. The current through this series circuit, which series circuit? This series circuit. The current through this series circuit for all t, the voltage drop across 4K resistor, and the voltage drop across 2K resistor. Right, that's all for this lecture. We will keep on solving more problems related to transient circuits in our upcoming lectures. Thank you.